Off the coast of Antarctica, deep underwater, researchers have discovered the British ship called Endurance.
There are so many places where that could very easily have gone wrong, and it seems absolutely miraculous.
Antarctica is more than ice and penguins. Under its white shell lie strange finds that rewrite what we thought we knew about the world.
There's no evidence the humans ever lived on Antarctica, let alone build pyramids there.
Explorers recently found the British ship Endurance.
Right here, this is where she sank. This is X marks the spot.
And scientists keep uncovering eerie surprises. Ancient DNA, hidden rivers, secret lakes, and forests scarred by volcanoes. This video races through Antarctica's top 15 most mysterious discoveries. Stick around until the end. The final reveal ties everything together, and you won't want to miss it. Number 15, the Endurance.
It's one of the most famous stories of survival of all time, the tale of Ernest Shackleton and the crew of the Endurance.
Imagine a great wooden ship painted black and white, pushing into a sea of white that goes on forever. That was the Endurance. In 1914, Sir Ernest Shackleton set out to cross Antarctica. The ship's name came from his family motto, "By endurance we conquer."
Shackleton seems to have had an ability who provided all the talents that he might not necessarily have had himself.
Everyone thought the Endurance would smash through ice and carry men across a frozen world. Instead, the ice closed in. The ship was trapped, crushed, and slowly squeezed until it broke and sank in 1915. What followed was not a hero movie, but a real-life test of grit. Shackleton and his crew abandoned ship, camped on the ice, then launched tiny lifeboats into frozen seas. Shackleton took a handful of men in one cramped boat across miles of angry ocean to fetch help. He did not give up on a single man. Every crew member lived to tell the tale.
But that's not just a smooth plain of ice. The ocean currents and waves cause it to buckle and crack and to rear up in great ridges and hummocks.
For over a century, the Endurance lay where the ice and sea kept their secrets. Then, in March 2022, explorers found the wreck on the seafloor in the Weddell Sea. It sat almost upright, as if planted there, the name still visible at the stern. The depth was enormous, around 10,000 feet, and the ship was amazingly whole for its age. That strange good luck comes from the cold.
You can see the Endurance's timbers still look as fresh as the day the ship was launched.
Antarctic waters are too bitter for the wood-eating creatures that normally turn old wrecks into sawdust, so the ship stayed whole in a way you'd never expect for a wooden boat. Tiny life had moved in, but not the kind that chews up wrecks. Instead, the hull became a strange garden of sea life, a quiet new home in a place where time seems to stand still. Scientists treat the site like a museum. They take images, measurements, and leave the wood undisturbed, so history stays readable for people in the future. And if you think that's the end of the surprises from the Weddell Sea, wait, there's something else that opened up there, and it's not a wreck. Number 14. Ancient DNA. Deep under the Antarctic seafloor, scientists found something like a time capsule. Bits of DNA from tiny life forms were pulled from the mud nearly 584 feet down. These scraps of genetic code are very old. Some may be as old as 1 million years. That makes them the oldest seafloor DNA ever verified. The DNA was found by chance during a 2019 ocean study. The team did not plan to dig up ancient genes. They were taking samples to learn about the seafloor. Later, researchers looked closely at the broken DNA pieces and checked how much they had worn down. That wear told the story of age. The oldest bits matched a time long before people walked where the ships now sail. How did the DNA last so long? Cold, dark, and low oxygen help. Deep under the ice and water, sunlight can't reach. and decay moves very slowly. The result is a rare record of life long ago. This record comes from creatures that lived in the sea and then left traces in the mud. Scientists call this stuff ceta-DNA, short for sedimentary ancient DNA. These tiny fragments let researchers peek at old ocean life and how it changed as the Earth cooled and ice moved. They add a new page to the planet's history book. With careful study, the DNA can show which species lived there, how food webs worked, and how the sea reacted to shifts in climate. It is like finding a whisper from the past buried under the sea. Listening to that whisper may teach us about how today's oceans might change next. Number 13. The Giant Hole. In 2017, a hole the size of Ireland opened in Antarctica. Scientists called that hole a polynya, a patch of open water inside sea ice. It was not the first polynya ever seen, but it was huge, about 78,000 square kilometers. That makes it the biggest seen since the 1970s and the first to appear in 40 years. The hole showed up in the Weddell Sea, a cold part of the Southern Ocean.
It's the coldest, driest, windiest place on Earth.
At first, this looked impossible. How could so much solid ice melt in one place far from land? The answer lies under the sea, not on top of it. In the deep water below the ice, the water can be warmer and saltier. Ocean currents push that warmer water up toward the surface. When the warm water meets the ice, it melts some of it and keeps the surface from freezing. As the warm water cools when it touches the cold top layer, it becomes heavy and sinks back down. Then currents carry it away. It warms again, and the loop repeats. It is a strange, steady cycle of heat, moving up and down. No one has a full answer for why polynyas start where they do.
Warming waters from changes in the environment are said to play a part in the formation of such holes, as well as weather factors.
Some scientists have guessed that animals like whales or seals may use these openings to breathe, and that might help keep the hole open sometimes. Others point to changes in winds or shifts in the currents. Researchers are still studying the cause and the result. These giant holes are a mystery and a warning. They show the ocean is alive with movement and heat. The more we learn about polynyas, the more we understand how our planet really works. What happens in the Weddell Sea can ripple out and change weather, sea ice, and life far away, and people. Number 12. Singing ice.
Scientists have released recordings of ice in Antarctica singing.
The Ross Ice Shelf is not just a slab of white. It is the largest ice shelf in Antarctica, hundreds of meters thick and about the size of France. That makes it an island of ice so huge it shapes the weather around it. Recently, scientists found something strange. The shelf sings. Strong winds sweep across the snow dunes and set the surface trembling. Those tiny shakes make near-constant seismic tones, a low, eerie hum that travels through the ice. People cannot hear the song. It lives below hearing, so researchers listen with seismic sensors planted on the ice. The discovery came by chance. Sensors put down to watch other ice movements picked up the hum instead. At first, it sounded like a mysterious noise. Then patterns began to show. The song changes when the ice changes. When the shelf melts a little or when a storm reshapes the snow, the notes shift. The ice reacts like a giant instrument. That means the music tells a story. Scientists now treat the hum as a live report from the ice. By tracking how the tones change, they can watch the shelf's health in real time. The slight shifts can hint at whether parts are weakening or if the shelf is more likely to break away. The singing is a simple, powerful alarm. The idea that ice can sing sounds like a myth, but it is science. The Ross Ice Shelf keeps a low, secret melody And listening helps people learn how this massive ice body is coping with change. The more the ice sings, the more it teaches. And for anyone who studies seas, storms, or the slow life of ice, that mournful song is now one of the clearest signals the planet gives. Number 11. Air-eating microbes. Imagine soil so thin and cold that almost nothing can grow. Yet scientists found microbes there that don't need leaves, sun, or buried food. They pull their energy straight from the air, tiny amounts of hydrogen, carbon monoxide, and carbon dioxide, and use those gases to stay alive. This surprise came from teams led by the University of New South Wales and collaborators who studied rocks and dirt from places called Robinson Ridge and Adams Flat in Antarctica. When they looked at the DNA in those soils, they found whole genomes from strange groups called WPS2 and AD3. Those genomes carried the tools to grab trace gases and even to fix carbon, meaning these microbes can turn air into food. What makes this huge is how tiny the fuel is. Hydrogen and carbon monoxide are everywhere in the air, but only in tiny amounts. These bacteria have special enzymes that can snatch those trace gases with high efficiency. That allows whole communities to live where sunlight and organic matter are almost zero. Scientists think this air diet helps microbes survive long, dark winters and the brutal freeze-thaw cycles of Antarctica. It also stretches our idea of where life can exist. If life can live off air on Earth, maybe life on other worlds could survive in strange ways too. Number 10. Gamburtsev Mountain Range. Under the thick heart of East Antarctica lies a ghost range, the Gamburtsev Subglacial Mountains.
The Gamburtsev Subglacial Mountains.
Mountains, right, but not just any mountains. These are apparently huge.
They run roughly 1,200 kilometers and reach heights up to about 3,000 meters, about a third the height of Everest. Yet you can't see them because 2 to 4 kilometers of ice sit above them. Scientists first inferred the range in the 1950s from seismic and gravity data, and later airborne radar and modern surveys mapped its shape under the ice. What puzzles geologists is age and survival. The rocks that make the Gamburtsevs are ancient, hundreds of millions to over 1 billion years old. So by normal erosion, they should be rounded lowlands by now. Instead, the range is oddly sharp and rugged. One strong idea is that the thick East Antarctic ice sheet has acted like a giant blanket, protecting and preserving the peaks and valleys from typical weathering. Another idea points to cold, frozen rock, or a cold shell deep below that slows erosion and keeps the topography intact.
And what's really interesting, unlike, say, the Transantarctic Mountains where you can actually see some peaks poking through the ice.
New studies using ice-penetrating radar, gravity, and even the rock's mineral clues keep refining the story, showing how mountain building, ice cover, and Earth's deep heat combined to freeze this secret range in time. Number 9. Blood Falls. In Taylor Valley, a creepy red stream oozes from the face of Taylor Glacier and splashes onto icy Lake Bonny. People call it Blood Falls. The red is not paint or algae, it's rust.
Blood Falls is a bit of an obsession for a lot of people. I mean, there's nothing else like this on Earth.
Deep under the glacier sits an ancient salty pool trapped beneath about 400 meters of ice. That brine is richer in salt than seawater, stays liquid below freezing, and holds lots of dissolved iron. When this iron-rich water pushes up through a crack and meets the air, the iron oxidizes and turns red, staining the ice like a wound. Even more eerie, the trapped brine hosts microbes that live without oxygen or sunlight, using chemical reactions with iron and sulfur to get energy. Samples and radar probes show this subglacial water has likely sat isolated for thousands to millions of years.
It's like this really visceral feature just jumps out at you, Blood Falls.
Making it a tiny, frozen laboratory for weird life and ancient chemistry. Because the dry valleys are remote and protected, visitors usually only glimpse bloodfalls from a helicopter or a specially routed Ross Sea cruise. It's dramatic, strange, and a powerful reminder that life and weird geochemistry can hide in the coldest, driest places on Earth. Number 8. Doomsday Glacier. They call Thwaites the Doomsday Glacier, and that name hangs heavy because its story feels like a warning.
The Doomsday Glacier seemed to be losing glacier mass quicker than previous projections.
This vast river of ice sits in West Antarctica and stretches about 75 miles at its widest. It acts like a giant plug, holding back a huge store of frozen water inland. What makes Thwaites worrying is how fast it moves. The glacier slides toward the sea quicker than many others. At its front, a floating shelf meets the ocean, and warm water has started to creep under that shelf and nudge the ice from below.
The ice loss of the glacier has doubled in the last 30 years, and some scientists are thinking that it could run out.
Where the ice once rested on rock, the grounding line is pulling back. As that line retreats, the glacier can flow faster and change shape. Why should people care? If Thwaites thins or breaks, nearby ice could speed up and pour into the ocean. That would lift sea levels and reshape coasts around the world. Cities, farms, and homes near the shore would face real harm.
In the Antarctic, the Thwaites Glacier is threatened the most.
Scientists do not all agree on how fast this will happen. Models give different answers. Still, teams from many countries study Thwaites because the risk is real. They use ships, drills, and sensors to see how warm water moves under the ice and how the glacier holds itself up. The story of Thwaites is both a puzzle and an alarm bell. It sits inside a larger problem: rising heat, shifting oceans, and changes that can pick up speed. Watching the glacier and learning from it matters. The more people know, the better choices can be made to protect coasts and plan for future changes. Number 7. McMurdo Dry Valleys. Most people think of deserts as hot sand and sun, not a frozen place. Yet Antarctica is the largest desert on Earth. It is bitterly cold, covered in ice, and gets almost no rain. In one small slice of that world lies the McMurdo Dry Valleys, a place that looks like another planet.
In the dry valleys, it's gone really well. We've knocked off pretty much all of our sample sites.
The dry valleys are almost free of ice. Wind scours the land, and the soil stays dry. Huge dunes climb high, some as tall as 70 meters and wide as 200. They look like movie deserts, but here the air is thin, and the ground keeps secrets. Scientists study the dry valleys because the place acts like Mars. The ground and the weather are similar to what rovers find on the red planet. Tiny life, if it lives here, must be tough. Studying the valleys helps people learn how life might survive in extreme places and what signs to look for on other worlds. The dunes are on the move. They creep about 1.5 meters each year. That is fast for big piles of sand in an icy place. Many researchers link the change to warming air and shifts in nearby ice. As the climate warms, frozen bits melt, winds change, and the dunes slip. This movement matters. The dunes shape the land and the thin life that might live under rocks. If the dunes move too fast, rare habitats could be lost. So scientists are hurrying to study the dry valleys now. They map dune shifts, sample soil, and watch weather. The dry valleys show something clear. Even the coldest places feel the reach of change. The secrets of Mars and the future of Earth both live in this quiet, windy corner. If people listen before the dunes shift away. Number 6. Ancient meteorites. Antarctica is a treasure trove for rocks from space. Meteorites fall all over Earth, but on white ice, they are easier to spot and often stay in good shape. Cold, dry weather preserves these stones.
So you're saying that as the ice evaporates, as the ice disappears from the top, the meteorites are kind of left sitting right there
on the surface.
Most rocks on Antarctic ice are not local. Little of the land under the ice can wash rocks onto the surface. So when dark stones sit on white ice, They are usually visitors from space. That contrast makes the hunt easier for the people who search for meteorites. East Antarctica is especially rich. Huge sheets of ice have stayed still for ages, while sun and wind slowly scrub away the top layers. This process brings older ice and trapped meteorites closer to the surface. Since 1976, teams have collected over 20,000 samples from the frozen fields. In 2013, a team of Japanese and Belgian scientists had a big find. In 40 days, they found 425 meteorites weighing about 75 kilograms.
So this is an example of an iron meteorite that's really super heavy.
Among the pieces were a chunk from the asteroid Vesta and a rock that began its life on Mars. The largest single find on East Antarctic ice in 25 years weighed 18 kilograms. Why does this matter? Meteorites are time capsules. They hold clues about the birth of the solar system, the mix of materials that built planets, and the early history of Mars and other worlds.
These things can make them career into the inner solar system and possibly crash down on Earth.
Each rock is a letter from space that scientists can read to learn how planets form and change. People keep searching Antarctica because the ice makes a clear map. The cold keeps the rocks fresh. The white surface makes them stand out, and the slow motion of ice gathers them in piles. For anyone who wants to learn what fell from the sky, Antarctica is hard to beat. Each find widens the story of space. Now it's time for today's subscriber pick. At the southernmost tip of our planet lies Antarctica, a vast, icy wilderness unlike anywhere else on Earth. Covering about 14 million square kilometers, it is larger than Europe and almost entirely blanketed in ice that, in some places, is over 3 kilometers thick. This frozen continent is the coldest, driest, and windiest place on the planet, with temperatures plunging below 80 degrees Celsius in winter. Its isolation is extreme. Surrounded by the powerful Southern Ocean, it is cut off from the rest of the world by thousands of kilometers of open water. Few people ever set foot here, and those who do face some of the harshest conditions imaginable. Yet, despite its remoteness, it has been the stage for incredible finds. From ancient shipwrecks to hidden lakes, the 15 mysterious things discovered in Antarctica prove that even the most desolate corners of our world can hold astonishing secrets. Number 5. Mount Erebus. Mount Erebus is one of the wildest places on Earth. Even in the frozen world of Antarctica, this volcano stays alive. It sits on Ross Island and climbs to about 3,800 meters. Unlike other peaks on the island, Erebus still spits heat.
Geothermal heat is that heat produced by the rocks of the Earth's mantle and crust. And whilst we may all intuitively think of rocks as cold,
for the last 1.3 million years, its lava lake has boiled and churned. In the last 30 years, scientists have seen even more activity than before. Reaching Erebus is not easy. The weather is fierce and the land is remote. Few teams can go there. In 2013, a small group hiked up through winds, snow, and broken rock to stand near the rim. What they found surprised them. Life had taken hold where you would least expect it. Tiny creatures lived in warm pockets of soil and in ice caves warmed by the volcano. These microbes survive on heat and minerals, not sunlight. Those strange life forms make Erebus a rare lab. They help scientists study how life can live in extreme places. The ice caves and hot ground show that even when the world seems dead, life finds a way. Researchers now watch Erebus not just for eruptions, but for the odd life it hides. The volcano teaches us about heat, survival, and how Earth keeps secrets under the ice.
And that's the source of the volcanism. That's why there's magma coming up near the surface and feeding this volcano.
Mount Erebus pulls the eye because it breaks the rules. Fire, in a frozen land. It is a place of danger and wonder. If you could stand on its rim, you would feel raw power under your feet and know that our planet still holds green corners of life in the coldest reaches. And wonder. Number 4. The Giant Pyramid. The Giant Pyramid idea hits a nerve. In 2009, a satellite photo showed what looked like a perfect pyramid under the ice in Antarctica. The shape had 4 clear sides and sharp edges, and people could not stop talking about it.
Several websites say the pyramids were likely made by an intelligent human civilization long ago.
Some saw proof of lost builders from long ago. Others thought aliens might be involved. The story grew quickly online. Skeptics answered fast. They said the image could trick the eye. Snow, wind, and rock can make strange shapes. Light and shadow on ice can hide bumps and make flat tops look pointed. Geologists point out that the Earth can make neat forms without any hands guiding it. Mountains erode and ice moves, and the end result can look made by people. Still, the thought of a real pyramid in the ice sparks the mind. It asks a big question. Could humans have lived in Antarctica long ago when the land looked different? That seems unlikely now, but the idea makes us curious. Some teams took another look with better images and radar. Most reports found natural causes. No clear proof of walls or rooms was found. This pyramid tale is part wish and part wonder. It shows how a single picture can make stories that range from hard science to wild myth. Even if the pyramid turns out to be a trick of light, the search keeps drawing eyes to Antarctica. It reminds us that the planet still hides strange scenes that make people ask big, old questions about who lived where and when. People love the mystery, and it pushes many to learn more. Number 3. South Sandwich Trench. The South Sandwich Trench sits where the sea falls away to great depths near the South Sandwich Islands. It lies in the remote South Atlantic and hides in dark water the shape of plate motion. The trench was not mapped well until late in the 1900s. In the 1980s, seismic surveys showed its true length and depth, and scientists began to study how it was made. This deep line in the ocean marks a place where 2 plates meet and one dives under the other. The South American plate slides beneath the small Sandwich plate in a slow, fierce shove. That process is called subduction. It makes the trench deep, shakes the ground with quakes, and feeds nearby volcanoes. The area is a seat of steady, raw change. For explorers and scientists, the trench is more than shape and sound. It holds clues about Earth's engine. The heat and pressure of subduction change rocks and push up new land. Around the islands, machines and ships watch for quakes and study lava from undersea vents. Life here is odd and brave. Strange fish, tube worms, and creatures that take energy from rock, not from the sun. The South Sandwich Trench reminds us that most of our planet's change plays out below the waves. We feel some of it as storms, small rises in sea level, or a far-off quake. But much of the shaping goes on where no one lives. Studying the trench is not just for pride. It helps predict quakes and shows how the sea may shift with time. Maps from places like this help keep people safer and inform future work. Number 2. Underground river. Far beneath Antarctic ice runs a river so long it surprises the mind. Scientists found a waterway more than 285 miles long. It sits under many miles of ice and finally drains into the Weddell Sea. The river was unseen until planes with ice-penetrating radar flew over and mapped the ground under the ice. This hidden river moves because of differences in salt and temperature. It runs through tunnels and channels beneath the ice sheets and links giant ice streams. The area it drains is huge, as big as France and Germany put together. The river flows under 4 major ice streams. As the ice melts back, water from the river can slip out into the sea. If the river's frozen cover thins or melts more, parts of the ice above could speed up and slide into the ocean. If much of the ice that the river drains were to melt, global sea level could rise a lot, as much as 14 feet over time. That would reshape coasts and cities. Finding the river is also a reminder that Earth hides big, active systems in plain sight. The water under the ice changes how ice moves, how sediments travel, and how the ocean takes in fresh water. Scientists are watching this river closely. The better we map it, the better we can guess how the Antarctic will change, and how that change may reach far beyond the frozen land. Number 1. Ancient fires. Long before Antarctica froze, its lands burned. Fossils found on King George Island tell a strong tale. About 75 million years ago, during the Cretaceous, forests in that region faced repeated fires. These were not small blazes. Many came from volcanic eruptions that sent hot ash and lava into the air and set trees alight. Researchers studying plant fossils saw signs that fires were common then. Burn marks, charcoal pieces, and layers of ash showed that eruptions and fire came back again and again. The work by teams from places like Brazil and Chile paints a picture of a warm, stormy land, not the white desert seen today. This past matters now because it shows how linked Earth's systems can be. Volcanoes change the ground. Fires change the forests, and both affect the climate. Antarctica's old forests and their fires give clues to how ecosystems react when the planet warms or when the ground itself changes. The frozen continent keeps those clues safe in rock and soil. By digging them up, scientists can learn how life once bounced back after hard times. That helps with one clear aim: to better grasp how our world might respond when new changes come. The story of fire in Antarctica reminds us that the land has moved through many states, and that each state leaves lessons we can use today.